Lift monitoring from exception to expectation. We'll jump straight in on this. What I'd like to do is, this is going to be quite a high level we'll start with a state of the industry as we see it today. So this is based on my research in Europe, in the US, and also my colleagues' research in Asia. So it'll be fairly broad strokes. I won't go into a great amount of detail on any one particular system, but really what I'm looking to come out of today with is having given where we view the industry today, trends in other industries and how that's going to affect ours. I suspect this presentation will be a great game of buzzword bingo when we start talking about things like smart buildings. But what I want to try and do is cut through a lot of that and say, well, really, what does it mean to us and what does it mean to clients in the lift industry? I'll then run through the options in the market as I see them today, and I'll give some fairly high-level pros and cons. Again, I'm not going to look to attack or push one system or another. What I'm looking to show is each system has its pros and cons, and there's different use cases for each. At the end of it, what I really want to do is spend a little bit of time on a lot of these big words which are coming in, IoT, artificial intelligence, predictive maintenance, and cut through a little bit of the hype. You see a lot of very exciting things on LinkedIn, and there are very exciting things going on in the market, but I think we need a little bit of a reality check just on a couple of the claims which are being made. So before we start, I wanted to just cover what we mean by monitoring, because you say monitoring to people or you say lift monitoring, and it can mean a bunch of different things. So as with previous webinars, we'll start with the dictionary definition: observe and check the progress of a quality of something over a period of time to keep under systematic review. So what we're talking about here is the current status of the lift installation, so a lift monitoring system. We're not talking about 3-day test calls for emergency telephones. We're not talking about any kind of tracking of technicians or lone worker alarms, which can sometimes get mixed up in this. We're talking about being able to monitor and understand the status of our lifts. So as I travel around and speak to different people, anyone who has a portfolio of lifts that they either have under service or that they actually own, one of the first questions I'll ask is, how many of your lifts have some sort of lift monitoring installed today? By far the most common response, and this is across Europe, America, we hear the same in Asia, is none. I don't have any kind of monitoring other than an engineer going and physically looking at controllers. Certainly don't have any kind of remote monitoring. The exceptions to that are what I would say specific installs, sometimes specific clients. We see monitoring in local government. It's popular with a lot of councils in the UK. Hospitals is another one where you'll often see something put in. Increasingly high-end commercial has moved to this as well. You see a lot of the EMS, elevator monitoring systems, in a lot of the high-end commercial buildings in places like New York, London, and so on. And in the US specifically, a lot of universities have embraced this as well. So I'll typically start with that first question: how many of your lifts have LMS? And then of those that have LMS, how many have some sort of remote access? And again, typically I'll get told none. It will be some kind of in-building system wired back to a building control center or even a security center in some cases. But there isn't an ability to reach in and see what's going on. I would say the exception there is probably the OEM systems, and we will touch on what the big four are doing here and what they've been doing for quite a long time. But I think the key point there is that access tends to vary to those systems quite a lot. In terms of, do you have a system that anyone involved in the management of that lift can access? That's actually still pretty rare. So LMS today, it's the exception, it's not the norm. It tends to be in-building systems, and there tends to be little remote access. But I think it's important to understand that that is changing, and that is going to change. So when we look at what's changing, we kind of need to look back at the history of really remote monitoring in general. So supervisory control and data acquisition, the old SCADA systems, began to emerge in the 1970s. And what you had here was the beginnings of industrial control equipment being connected into either local area networks or directly to some sort of terminal, and it gave monitoring data back. As I say, that originally came from industrial processes, particularly industrial automation, but it began to spread into buildings, and we're always concerned with what's going on in the built environment in this industry, through heating, ventilation, and air conditioning systems. Also access control systems to a slightly lesser degree, but really it was about that HVAC control. By the early 2000s, we began to see SCADA systems being connected to the internet that allowed remote monitoring, remote access, and an element of remote control. It's worth noting that there had always been analog systems, systems which effectively ran almost as a data fax, and those had been around certainly since the late 80s. Building automation, and then more importantly, building management systems have then really started to proliferate in that same timeline. Most of that has been driven by energy monitoring and specifically energy cost savings. If you speak to most BMS people today, they'll talk to you about monitoring and controlling your heating and ventilation to save energy costs there, and monitoring and controlling your lighting to save costs there. So today we've begun to talk about smart buildings. Well, smart buildings, what does that mean? I pulled this from the Smart Building Show last year because I thought it was quite nice. It's a connected building which is seamless and speaks one language. So we're absolutely moving toward a world where customers' expectations are, I can connect to and monitor pretty much every building system, and typically I'll be able to do that on one platform. So when you begin to talk to property managers and you begin to talk to people in this space, you start to have this conversation around, well, to a certain extent, the rest of the building, or certainly key systems, has been connected for the last 30 years. Why not the lifts? Why do the lifts stand on their own as this critical building system, which typically buildings have little, if any, insight into? Now, we know that BMS providers are now being actively pushed by their clients to start to provide lift and escalator information. A BMS provider in the UK, a well-known one, actually gave me this lovely little quote, which was, if BMS is a dark art, lifts are a black hole. So who's going to drive this change? Who's going to drive this connectivity of the lifts? And I think ultimately everybody at every point in our industry needs to start asking themselves that question. Because if it isn't you, it's going to be one of your competitors. That's true for people like Avire who make equipment, but it's also true for people who provide maintenance. It's going to be true for people who are writing specifications, because there is going to be a pull from the client side, and it will be people like the BMS providers helping drive this for that connected lift, that level of understanding and insight, which the vast majority of installs just don't have today. So what do we have in the market? Well, the first place to always start is with, what are the OEMs up to? So OEM systems have been around for a long time. A great example is always the Otis REM. And in the last couple of years, Otis have started to use the tagline, connecting elevators for 30 years. So REM's a good example of one of the analog systems that emerged in the early days. Began with transferring data back every 8 days, and at its heart, an analog system when it began, and it also has some of the emergency comms tied up in it as well. These systems could provide most, if not all, controller data. A lot of the older systems have been upgraded to move away from landlines now to GSMs. This might be a little controversial statement, but I think we've all heard it. There's an unfair reputation in the industry, I believe, that these became a replacement for regular maintenance. It was seen that, oh, well, we've got a monitoring system on there, and that's not just Otis, that's true of all OEM systems. There's a monitoring system on there, so we don't need to go out and look at it. I suspect in some cases, like everything, there was an element of that, but I don't think it was the norm. The issue with these is they're brand specific and they're closed protocol. If you have an Otis system, it works on an Otis lift. If you have a Schindler system, it works on a Schindler lift. And guess what? It's Otis and Schindler that can access these. Client access varied. You saw some clients who would have a screen in the building reading out information. Others, this would be more a tool that the OEMs used. That's begun to change. And when I talk about who's driving the change, I think it's very important for us all to be aware of these offerings. So Kony 24/7, which is a connected maintenance service, which they're partnering with IBM Watson to develop. Schindler Ahead. Schindler have partnered with Huawei for hardware and General Electric for a lot of the software. The Otis One system, which again is, I suppose, the ultimate evolution of REM. A lot of these are making big, oh, sorry, nearly forgot Thyssen. I do apologize to any Thyssen people on the call. Thyssen with the Max and Thyssen with their HoloLens system are very much looking at a connected lift, more from the point of view of diagnostics, I think. And all of these are very much around the engineers and engineering supervisors being able to provide a higher level of support. Really today, these are giving real-time information back to service leaders and so on to be able to make decisions. The standout is probably Thyssen with that HoloLens project, where you can see the guy sat at his desk there with the little set of goggles on, able to view everything that's going on in the lift. In theory, a Thyssen technician would then have a similar thing at the installation side, and it would be popping up data about the lift he was working on. So a lot of work's been done there. It's important to remember that for things like REM, for things like the Connex from Kony, there's years of data built up there. So these guys really have a head start when it comes to doing some of the more complicated things around predictive maintenance and so on. But again, these are all going to be closed protocol systems. Otis can work on Otis Run, Kony can work on Kony 24/7, but we won't have that crossover. So a lot of that downside or potential downside for the client hasn't really gone away. If we're talking lift controllers, it's important to speak about the package lift suppliers and the independent controller manufacturers. A lot of the third-party controller manufacturers are increasingly offering monitoring and also remote monitoring. We've had a number of conversations with different people doing different things in the market. I've snatched the McPherson Sigma for lifts from their website purely because it was the first one I came across. We're not saying that you should use that over anyone else. There's a lot of good systems out there. Again, because it's being provided by the controller supplier, it can provide pretty much all of the controller data. And we see these today primarily being used for remote diagnostic. The controller supplier can dial in, tell you what's wrong with the controller. A lot of it's used at setup to kind of catch those first fix problems where people have maybe configured things incorrectly or there's some other problem. And again, with these, it's fair to say that client access varies. Most of these that I've seen, the controller manufacturer has access for that remote diagnostic, and the service provider potentially has access as well, but again, primarily from a fault finding point of view. So the pros from these, they are open protocol in the sense that anyone who picks one of these up will be able to work with it, which is great. There's an increased use of GSM, so that in turn leads to an increased amount of the remote monitoring. The cons with these, they are brand specific, but equally they're being provided as an added value for the controller, so that's no real surprise. Typically, and I think this is still broadly true, you do require a new controller, or at least you require significant upgrade to your existing controller. So that's great if you're fitting new lifts, if you're doing major modernizations, but from the point of view with someone who has a large number of units under service, an aging install base, which we see all the time for specific institutions. You can have hospitals with old lifts, you can have universities with old lifts. But when you really start to look at things like social housing, transit, they've got hundreds of lifts which have been going in probably over the last 40 years, and some of them are still in service. So either tear out the controller or start again, or you need to look for another option. So moving on to the next, there's the retrofit solution, or what I call the bolt-on or tie-in systems. Again, a lot of these have been around for a long time. You'll have some sort of interface module to access the controller data. I've shown one of our boards from Emotif there for our Emotif LMS offering. Other brands are available, of course. These are typically in building systems, but there are increasingly options with a GSM, with remote access. And the way I like to look at these is to say it'll give you 90% of the data you want from maybe 70% of the controllers on the market. So the pros to these, you can usually keep your existing controller. There is typically some form of client interface, and they are fairly customizable. We've done work in the past in the Middle East where we've had to work with a controller provider to actually open up the LMS for clients. It's a fairly long process. It requires the signing of NDAs and so on, but it can be done. A downside is you do require access to that controller protocol. So if for whatever reason the controller manufacturer doesn't want to work with you, and we've all seen this before with closed protocol systems, that can be a blocker. The installation for these is fairly labor intensive as well. You typically need to pick up on individual discrete wiring or so on from the controller. And that all adds to the cost. And these systems, just from a hardware point of view, can be costly to begin with. So there's an option that's been around for a long time. What I would say is the newer options on the market are really the beginning of these, what I call IO solutions. So these are probably the simplest retrofit solution today. And all you're looking for there is to pick up on simple signals such as dry contacts and so on, which you can then interpret as a controller signal. So what do I mean by that? Our Connex device that you can see there has an out of service input on it, and the inputs are along the top here. And all we'll say to a customer is, if you can give me a 10 to 30 volt DC signal, which you would judge to be the lift going out of service, and wire it in there, I can report an out of service signal on my monitoring platform. So pretty basic, but when it comes to that, is the thing on or off? That's usually the first goal that you want to hit when you're monitoring something. And it's surprising when you ask people what are the top 5 things you'd like to know about your lift. Typically the number 1 is in or out of service. You have the option with these as well to add outputs. So on our device, we have those 2 relays on the bottom, and that can allow you to potentially reset equipment. I know there's a big debate about the how sensible and how safe it is to remotely reset devices, but we do know that goes on. And there are also use cases you can see with these where something would happen, and so you'd want to trigger something else. You see a temperature increase, so you want to switch on a fan, or you want to switch on an air conditioning system or so on. With these, I think you're probably looking at something like it'll give you 60% of what you want, but from 90% of controllers. So we're flipping it slightly there, where it's more basic functionality, but it can be applied across a lot more kit. So the pros with these are they're simple to fit. I'm not looking for a specific discrete contact. I kind of give me any sort of signal and I'm happy, provided it's within those voltage ranges. The hardware is the least expensive solution available today, I would say, in the grand scheme of things. It'll work on most controllers, and actually because of these setups, they tend to work better on the older controllers where there's more of these types of outputs available. Does open up the options to add sensors, and I'll talk about that a little bit more on the next slide. Cons to these, the obvious downside that I've touched on there is you have a limited amount of data you can now access. That unit has 5 inputs on it, so it can monitor 5 different things. If you're looking for every single fault code out of a controller, though, you'd have to put a lot of these in and do a lot of wiring. So you're probably today better off with one of the bolt-on systems, although that is beginning to change. Going back to the point I made there about simple to fit, the caveat I would add to that, so it immediately becomes a con, is you do require a good level of knowledge of the lift controller wiring and an overall good understanding of the circuitry on the lift. It's dead easy for me to sit here and say, just give me a 10 to 30 volt DC contact that you would interpret as out of service. And certainly when I speak to a lot of service supervisors and so on, you know, we sit there, we scratch our heads, we work out how we do it. Yeah, we have to acknowledge that there is potentially a lower skill level at times in the field. So it can be a challenge for some engineers actually when faced with this on the lift to be able to find that. And whilst we'd all live in a world where every single lift still has its original wiring diagram nicely stored in the motor room, we know that the sad truth of the industry is that's not always the case. So that can take a little bit longer. It's by no means impossible, but I think it's something that we have to acknowledge. Where we start to move into things which probably at this stage are a little bit more conceptual, but in the last couple of years have been realized in a better way, is when we talk about sensorization. So the nice big headline here is forget about the controller, because at this point, I'm not looking for signals from the controller, signals for the lift. What I'm talking about here is we deploy an array of sensors, and we can pick up on various status. So we have a nice little diagram of our lift shaft with our nice big motor room, our controller cabinet here. But what we'd be looking to do is place sensors at key points in the installation to begin to measure and understand what's going on. So I've put that little sensor board there, nothing to really scale it against, unfortunately, but those are about probably 25 to 30 centimeters square. And this allows us to do some quite clever stuff. So if I can pick up on acceleration, I can potentially give you position of the car in the shaft, so I can give you what floor it's on. I can certainly give you speed, and we all know that a decrease in speed can mean a number of different things. And I can also potentially, if I can get that acceleration on the door, I can give you the door status. Are the doors open? Are the doors closed? Have they started to close slower? Do we have something stuck in the sill? Are they trying to close and they can't close all the way, so they've started to reopen? That's a pretty good way to ruin a door controller. Temperature is an obvious one. There's the high-level version of operating conditions. Is the air conditioning broken in the motor room and I'm now running everything too hot? Obviously, the flip side of that in this country is, are all my motor rooms getting too cold because it's the depths of winter? And am I about to have things falling over en masse because I've got exposed motor rooms on the top of high rise or so on? So do I need to send guys out to start putting heaters in? And then equally, do I need to then see that temperature start to rise again in the spring so we can go and get those heaters back? The other thing a temperature increase can give you is, if you're monitoring that temperature at a specific discrete location, is it showing a sign of wear? Is my motor starting to run hot all of a sudden? Am I picking up weird temperature readings at certain points on the car? Vibration gets talked about a lot, and with vibration, again, we're talking about wear. The vibration pattern has fundamentally changed on this part of the machinery in, I know, let's say the last month. We should probably go and look at that. This also gets you into the very kind of vague world of ride quality. Now, we've all been in lifts that bang about in the shaft and said to customers, not sure if this is right, perhaps we should have a look at it. But if we could get to the point before the customer is irate that the lift is banging about in the shaft, and we could start to see those vibrations creeping in, it would allow us to potentially catch things earlier. And that's what then leads us down to the route of what I would call preventative maintenance. I can see a weird vibration here. Let's go and look at what's wrong. You obviously, as well as the sensors, will require some sort of additional communication hardware. We see this in the form of GSM, units that will pick up on building Wi-Fi and so on. And we've also begun to realize that it's a little bit unfair to show you these nice 30 by 30 boards with no way of reasonably connecting it into anything in a real world situation. So again, I'll use the example of an Avire product here. This is the lift hawk, which will sit on top of the car, and by understanding acceleration can understand whether lifts are in and out of service, whether they're moving. And what we've done there is we've packaged those sensors together for you in a box to make it much easier to fit. Pros on these, and put this under a pro, it does lead to totally different pricing structures. You can start to talk about things like leasing equipment. The longer, I'll lease this equipment to you rather than have an upfront cost of the building. And it allows you to do certain other clever things there as well. This is the ultimate open protocol device because, as I've said at the top, it allows us to start to forget about the controller. And sensors are simple to deploy. If you look at that lift hawk there, all you need to get that on top of the car is 4 self-tapping screws. You connect back to our CAN bus, you can start to get that kind of data out. Likewise, our Navbox product comes in literally the exact same black box and can give you position, speed, and so on. The cons to this, when you start bringing raw data back, you do still need an expert to interpret it. What do I mean by that? If I show the average building manager the vibration pattern for their lift, they'll go, thanks, what do I do with this? But if we as people in the industry start to look at it, and we've done this countless times with service and repair supervisors, mod managers, you name it, we say, okay, this was the vibration pattern here. This is how the vibration patterns change. What does that mean to you? Often guys can start looking at this in the exact same way people used to go into motor rooms, hear a noise and go, oh, I know that's a bearing out. We're beginning to see people who can do this with the data. Oh, I can see that wear pattern change. I know what's going wrong. A lot of these systems are being oversold, in my opinion. And that's what I want to lead on to with my last slide. Sorry, not my last slide, my last but one slide. This is just a quick look at our LMS system. We're calling it LMS Light to differentiate it from our full system with Emotive. And what you're looking at here really is a combination of the input-output approach I spoke about and sensorization. So on this side of the screen, we've got lift status. So we have this installed on the lift in our Barcelona factory. You can see what floor the lift is on. You can see if the doors are open or closed. You can see things like height of travel, total number of trips, distance traveled, velocity. So again, when I talk about being able to see the speed, and there's various other bits like out of service, fire alarm, and so on we can pick up on. At the same time, we're reading off equipment status from different things we have installed on the lift to give you that kind of full, not full picture, but a much broader picture of what's going on than you had previously. Now, I've talked a lot about buildings and clients here. Let's not forget that all of this could be really interesting data if you were being called to a breakdown. You've got a customer on the phone who's telling you my lift is broken down. I want someone out here this minute. Well, I got to put an engineer in a van. That guy's got to hack 3 hours across town to work out what's going on. But if I pull this up and I start looking at things like, where is the lift? Are the doors open? Are the doors trying to close maybe? Because how many times does an engineer get to site and it's running on arrival? Well, depending on your contract, you potentially still get your 200-300 quid call out charge. But what else could that engineer have been doing for you? Potentially more profitable work. Because it turns out that somebody on floor 4 had propped the doors open, had forgotten to tell anyone, and someone on the ground floor is pressing the button shouting, this lift doesn't work, what's going on? So that's just a view of really what's available today in this world. When I talk about things being oversold, and I told you we'd do a bit of buzzword bingo, it's really in this world, IoT, Internet of Things, predictive maintenance, all of these. So let's just knock down a couple of bits and pieces about what we're really talking about here. With Internet of Things, and I won't read out that whole long Wikipedia explanation, but we're talking about different devices connected to the internet, which is able to transfer information back, which will either then, sorry, excuse me while I choke there, transfer internet back without the need for that human to human or human to computer interaction. So for our industry, what we're talking about here is I can read off the controller data sat here at my laptop without sending an engineer to site to look at the display to find out what's going on. So that's your Internet of Things, where we then start to bring in all these other words. So artificial intelligence, data analytics, big data, there you go. That's a good lot of things. Put simply, the more you know, the more you can do. So as these companies begin to build up these big databases of information, they can then apply algorithms to that to say, okay, we saw this pattern of data from these type of lifts and it led to this sort of breakdown. That's where we really get into this predictive maintenance. That's where we really start to get into the dream of, I can start monitoring a system and I can tell you ahead of time what's going to go wrong. There's a few things you need to hit before you can do that though. The system needs to have acquired enough data that it can start to predict the true lifetime of components. Do we really think anyone is at big data yet? No, probably not yet, possible exception of some of the OEMs. And when you're talking to people about these systems, Or rather, when someone is trying to sell you one of these, I would advise you to ask one question up front. And that is, give me an example of one thing your system has predicted. Just one thing. Because most of them won't be able to do that, which is fine. And they will get there. These are very, very smart people. But let's understand today, what we'll be buying into is a monitoring system. It'll give us real-time status. It'll give us event logging. What I don't believe any system can do today, and I certainly haven't seen any that do this, is something that you can drop on top of a lift and it'll tell you, okay, in 6 months' time, here's what's going to go wrong. Here's what you need to fix. But they are going to get there. And this is where I go back to what I said at the beginning around someone is going to drive this change. Clients' expectations are changing. Everything in the building is connected. Why not the lifts? You know, property managers are great fans of saying, why is it I can switch on the heating in my house from my smartphone, but I don't know if the lift in my building, this critical system, is working or not? I think BMS companies are going to drive that change. So I think that's increasingly an area we need to be aware of and we need to be open to working with. Retrofit solutions are out there. It's not a case of sitting back and going, well, either you buy a whole new lift from an OEM or a package supplier or a whole new controller. There are things that can be done with those older install bases, with those customers who potentially don't have the money to spend on new controllers, which will start to give you some of this functionality. Be easy to dismiss things like predictive maintenance, but it will happen. But today, when someone's trying to sell it to you, give me that example of one thing your system has predicted. If they can't do that, there's nothing wrong with it, but just understand what's being talked about and what you're being sold on. So, as always, I think I'm very slightly over time there, but I think we are getting a bit better at this. I'm maybe only 5 minutes over. Em, do we have anything on the Q&A?
Yes, we do have a few. Please, anyone that has any questions, please put them in. How does the lift hawk detect the difference between a lift out of service versus just at rest between calls?
So the lift hawk isn't just, oh dear, I've fallen into my own trap that I berate my salespeople for not explaining the full value. Lift hawk is looking at lift movement, but it's also understanding what the typical pattern of movement is. So if we set a lift hawk running on a Monday morning in an office building, it's going to see probably a large amount of moves at the start of the day, around lunchtime, and in the evening. People coming to work, people going out to lunch, people going home. So it'll understand, okay, I see a peak in the morning, a drop off of activity, a peak in the afternoon, a peak in the evening. It'll see little to no movement on a Saturday and a Sunday, but it will begin to learn and understand its typical movement pattern. So it's bank holiday Monday, it's 9 o'clock in the morning, I'm not moving. That's not right. So you can then wire the lift hawk to typically the ground and the first floor call buttons, and it will actually energize those buttons and try and make itself move. The reason we do that is not just for catching when's a bank holiday. It's more about being able to catch, okay, it's Monday morning, I would have expected to start to see some movement and I'm not. Let me just do that test, because if I do that test and I can't move, so call into first, did I move up? Yes, no. Call into ground, did I move down? Yes, no. It can then report to you and say, right, I can't move. Fundamentally, for some reason, I'm out of service. So that's the kind of very quick explanation on that. Hopefully it answers your question, Paul.
Yeah, also you could have it set for a time period. So you could have it earlier in the morning and check it so that you could make sure that the office or whatever building is up and running, right? Okay. Does or will lift hawk develop with other sensor inputs, for example, car, lighting, and leveling, etc.?
Will it necessarily be on lift hawk? I don't know the answer to that. We are looking at, essentially there are a number of hardware platforms we could build out sensorization from. Lift hawk is one, the nav box is another. I suspect long term what we'll be giving you is one box that does a variety of things, but certainly we are looking at the list of We have a list of sensors that we could develop, we could integrate, and what we're doing at the moment is prioritizing that. So certainly things like car lighting, car leveling are on there. Plenty of people talk to me about water in the pit. Other people talk to me about being able to understand if you've got seepage on hydraulic fluid and so on. So what I would say in answer to that is, yeah, it might be LiftHawk. It might be something else, or more likely it'll be a sort of separate platform entirely. But you'll see development on that over the next sort of 6 to 12 months as we really start to build out on our sensor offering.
Yeah. Okay. Adrian has asked a question, and Adrian, if we answer this wrong, please send another question, because I'm not sure. What if you can't place a call? So I'm presuming if that's the lift, what happens if the lift can't move? Is that what you're...
So yeah, I'm guessing that's what Adrian means, that he means what if you can't actually place a car call? Well, if you can't place a car call and you're still not moving, the LiftHawk would report an out of service. It's never going to be perfect. It's never going to be as good as having that specific fault code out of the controller. But effectively, if it thinks it should be moving and it can't move, either because it can't place a call or for whatever other reason, if you've got a building that's trying to load in the morning and it can't move, we judge it to be out of service, so we report out of service.
Great. So interesting question here from Paul. What security protocols do your systems work to?
I don't have that list off the top of my head, but we can certainly follow up with a list of those. What I will say is all of our cloud systems are hosted on Microsoft Azure, so there's obviously a high level of security and reliability there. We've also done a lot of what's called pen testing, penetration testing, effectively with hackers who've come in and looked at our system and looked at different ways in which they could, you know, basically show me how you could get into it and break it, and I'll fix that. So we did all of that before we launched anything, but I'm more than happy to have one of the guys follow up there with the specific list. I think we've also got information on the website on that.
Yes, we do. There is an article somewhere in our blog.
Okay, that's a good one to send a link to.
Does the Avire LMS tie in at all with the Avire emergency communication system, for example, Memcom, DCP, etc.? Are they completely separate systems? So we have two. We have LMS and we have LMS Light currently. So Matt,
so LMS Light is a seamless tie-in. It's the same DCP that we're using to report the data out. If you then have the emergency comms in there, and obviously we'd like you to, it'll all still connect up. It all goes back to one platform. Anything that we add moving forward, we would show on the Avire Hub platform. So going back to the slide that I showed on, am I going to completely break everything doing this? No. Good. You can actually see off to this side, off to the left side of the screen, you've got your status from your DCP, you've got your status from connected digital audio units. So as part of that LMS Lite, you are getting an understanding of what your emergency communication system is doing. And of course, you would get your 3-day test calls back to this platform as well.
Exactly. Are there different levels of interface, one for end users, one for maintenance companies, etc.?
There absolutely are. I think we'd all be very, very nervous if building clients were able to get in and reset things and so on. Essentially what we would do when we set up a customer on this, there is a high level kind of super admin who can go in, create accounts, make changes and so on. You can then set up different profiles down to and including a read-only and a read-only for certain installations. So obviously from a lift company's point of view, you're going to want to be able to see all, I know, 300 or 350 lifts you've got under service. But of that install base, maybe only 50 are for one client. You want to be able to tag those 50 and then say, okay, I've given my client read access, but only to those 50. So yeah, there's a variety of different interface levels. Our sales guys can explain that in more detail if you'd like. I've obviously given a very quick one there.
Another question here. If there is no open protocol from lift controllers, can you provide lift monitoring systems with minimum dry contacts?
So that would be the Connect solution that I spoke about when I talked about IO solutions. So yeah, provided you can find those contacts, provided you can tie them in, then yeah, we'd be able to provide monitoring back for those.
Okay. What time is it? Oh, got a couple of minutes left. So in terms of data usage over GSM, do you have a rough idea of what would be required for a standard lift, as it would need a higher GSM contract cost?
That's an interesting question, actually, because we start talking about this and you imagine that it's very, very heavy data handling, but it's really not. Specifically, if you're only asking things to report events back and so on, I would say that you would be well within the typical data plans, certainly well within the data plans that we sell on our SIM cards. When you get into systems that want to stream live data back 24/7, they can get a bit heavier. But really, with most things today, all we want to see is the event. The way I often describe this to people is I don't want to see everything that's going right, but I do want to see as soon as something goes wrong or as soon as something changes, which I think is out of the ordinary. Your data usage will vary by how many things you have installed and what you've set them up to do. But certainly, you know, the average data plan that I see and the data that we offer on our SIM cards, you would not get through that.
Quick final couple of questions. Can they link via the building's broadband?
My answer to that is not yet. We have obviously invested heavily in GSM technology over the last 3 years. Partly that's to support emergency communication and the changes that we've talked about in previous webinars when it comes to the fact the landline is going away. Also, if you can get the information out through a GSM, there is a value there in terms of ease of installation, because if you're trying to get out through a building's network, firstly, you've got the various firewalls and so on to contend with. You've also got how comfortable is the average client having you putting something on their network. I have heard instances in places like New York of certainly financial institutions when they're talking about connecting the LMS, wanting the LMS provider or even the maintenance provider to take out separate cyber insurance, as in if your LMS system breaks my security on my network, you can bet that I'm going to come after you. That said, GSM is not the only solution, so we are developing systems that will allow the building LAN to plug in directly. We're a little ways off from that yet, so we're not in the position right now to talk about anything. And I know I sound like a little bit of a broken record on this sometimes, but later in the year, we will start talking about things like that, because we do acknowledge that there are use cases where you want to go out through the building broadband, maybe even through the building Wi-Fi. So yeah, that's certainly on our roadmap.
Okay. Matt, do you want to pick one more question and then we'll wrap it up?
Okay, so open the question and answer method.
I'd give you the choice of your final question.
Here we are. Is the sharing of lift data equipment status via API the next? Okay, so APIs are worth touching on. Increasingly, we find, certainly when we talk to the BMS providers, buildings don't want multiple systems to look at. They don't want one system for the heating and ventilation, one system for the access control, one system for the lifts. They want a single platform. And that's where a lot of the kind of BMS integrators have really carved out their niche and done a lot of very good work. So increasingly we can, and when I say we, I mean the lift industry, can install hardware, can set up platforms and so on, but it's entirely likely your client will then want that data out of that platform into a standard dashboard they're using from somebody like AimTech or so on in the UK. That's an example of an integrator you can go and look at. With people like that, there then needs to be what's called an API, which is essentially a link out from our platform into their platform. We've done some early work around this. We do have an API available. So if customers are asking for that, if they've got their BMS partner in the room, that's certainly a conversation we can have. So yeah, that is very much something we're developing.
Thank you. Right. Thank you for joining, everybody. If the survey does come up, please answer it and give us some feedback. It's always really helpful. We're looking for more topics to run, so if you have any ideas, please send me or Matt an email, and we'd love to present some more to you. And we will see you soon. Thank you for joining.
Thanks all.
Bye.